Okay, for this particular question here, I know it's broken up into questions 2 through 5 here, but we're going to do them all basically at once here. So the following are the graphs of polynomial functions. Okay, and when you look at those, I hope at this point here you're comfortable enough with this to realize that they're all cubics. Okay, this is a negative cubic, this is a positive cubic, this is another positive cubic, and this one's a negative cubic. Okay, just because of the way they're working here. Now, the question says, which graph or graphs above illustrates a function with the following characteristics? If more than one answer, then we're going to list the numbers from smallest to largest. So here, where is a positive and one of the factors is x plus 2? Okay, well, to have a factor of x plus 2, we're going to have an x-intercept of negative 2. So we're looking for something that's going up, positive here, so that's these two right here. And which of these two goes through x equals negative 2? Well, the answer is it's not this one. This has got an x-intercept of negative 1, positive 1, and positive 2, but that's not the one I want. I want it to be negative 2, because remember how this works. If this is a factor, okay, then it will cause the whole polynomial to go to 0 if this is equal to 0, and that will only equal 0 if x is negative 2. So it's got to be this one right here. It's got to be graph 3. So right here, graph 3. Here, a is less than 0, so it's one of the ones going down. And the 0 is x equals 2, okay, positive 2. All right, so this one's going down, this one's going down. This one's got a 0 at negative 2, negative 1, and 1. Okay, well, it can't be that one. This one's dropping down, and this one does have a 0 at positive 2, so the answer to this question here is it's got to be graph 4. Next one says a is less than 0, so again it's going down, has a constant of 2. Now they're talking about in the expansion. So this means it's got a y-intercept of 2. And then 3 distinct zeros. Okay, so first of all, a is less than 0, so it's going down. So it's got to be one of these two right here. It has a constant of 2, meaning the y-intercept is 2. Okay, so that's got a y-intercept of 2. So does this one. Okay, so it still could be either one of these. But then the next thing here says it's got 3 distinct zeros. But this one doesn't. This one bounces off the x-axis right here. So there's 1 0. Or if you ask somebody who's really into mathematics here, they'll tell you that no, there's 2 here, but they just happen to be the same. Okay, and that's how you're supposed to interpret that. But the result is they're not distinct. You've only got 2 distinct zeros here, but up here you've got 3 distinct zeros, 1, 2, and 3. So the answer is this has got to be graph 1. And then the last one here says the end behavior is that from quadrant 3 to 1. Okay, quadrant 3 to 1 means you're starting here and you're going up. So this is basically meaning that we've got a positive a value here and has 2 distinct x-intercepts. Okay, meaning that we're only hitting the x-axis twice. So this one and this one, well, here we're hitting it in 3 distinct spots here. So this has got to be the one they're talking about. That's, once again, we're talking about graph 3.